Okay, let's start with OSI layer we discussed. I'm keeping on repeating this OSI layer because that will give you a bit of an idea in the future as to how you should relate every devices involved in networking, because that's the fundamental framework with which every software that is developed around networking works. Things have changed significantly from how it used to be honest, 5 years ago, right? 5 years ago, the protocols, the application protocols that is being used and what is being used today has evolved quite significantly, especially in terms of, all the 5G and those kind of heavy broadband or heavy bandwidth devices coming in. The way people used to perceive networking initially has changed. What I'm planning to do today is to sort of talk to you about, we spoke about OSI layer, which are the 7 layers of networking. OSI. Today also we are going to talk about, excuse my handwriting, okay, TCP IP. We are also going to talk about UDP. Okay. Okay, let's do it. This 1, 2, 3. How many layers in OSI layer?
So 7.
How many? Okay, so how does it start? Let's start with physical layer, right?
Physical.
What is next?
Data link.
Okay, I'm just doing the short form. Next one.
Network.
Next one. Transport. Remember the, if you want, remember the short form that I used. Please do not throw.
Pizzas. Sausages.
Yeah, presentation layer, session layer,
Session.
and application layer, right? So this is the fundamental based on which any networking, I wouldn't say protocol, the mechanism through which any data communication happens. Yeah. In it, the next protocol that I'm going to talk about is TCP IP. So OSI is not something, it's a basis. People sort of started working on new ways of implementation of OSI layer. And one of the major implementation or a popular implementation of OSI layer is called TCP IP. So when I say that, what I mean is that OSI layer is the theory. Based on that theory, new concepts came out. Okay. And you can, this is just for your understanding I'm talking about. TCP IP is one of the most famous, when I say famous, one of the most popularly used implementation of OSI layer. Okay. And the reason being, it was a protocol which was developed, which could be sort of, for want of a better word, it could be applied to a lot of scenarios, lot of communication channels. Okay. And how they did it is they sort of grouped application, session, presentation layer into one. And they said, that's all application. All right. They kind of said, okay, I know within the application, you've got application layer, session layer, presentation layer. I don't really care about how you do it. Just give the data packet in such a way that all those information pertaining to application, session, and presentation are available. And then they also added transport layer on it, network layer, and then it's the physical layer, right? So that's one of the most frequently used, popularly used implementation of TCP/IP or OSI model, and that's called TCP/IP. The reason why TCP/IP became popular is also because a lot of the devices started using that kind of structure, which means that you can have a network switch with an operating system on it. Look, any device, if you look at it, which is actually connected to internet and you call it as a network element, contains an operating system. You might have probably gone through the sessions with other IT colleagues within GrainEd has explained. Every single device comes with an operating system. An operating system is what? An operating system is a software which sorts of talks to the hardware, correct? In a very basic format. An operating system is a software which actually talks to the hardware. No other software directly talks to the hardware, because any software which kind of talks to the hardware is called as an operating system. Okay, so if you look at any electronic device that is being manufactured, contains an operating system. Be it your TV, which is called an Android operating system, or I mean, all the modern ones, not the electrical TVs that we used to use before. Be it your phone, the phone has an operating system. You call it an Android phone or an iOS phone or a Google phone or whatever, right? You know, it always uses an operating system. Why? Why? Because that particular software interacts with the various devices or various physical devices within the operating system, and it sorts of what you call it collects data from that and sorts of creates a communication channel to each and every device. Say, for example, if you have a laptop, you will have a network interface card, you will have a PCI card, you will have an HDMI card. All of that software, all of those devices will be chatting between each other and chatting to you, okay? Because you want to connect a screen through an HDMI cable, you want to connect it through a USB cable to an external device. All of this chatting happens through the software called operating system. So TCP/IP became a major implementation of OSI because with TCP/IP just left the responsibility of encapsulating application, session, presentation information into that operating system / software. Make sense? You know what is encapsulation means? Look, if I'm giving you, while I'm talking, if I'm giving you a bit of a buzzword or some sort of weird words to you, just call out and ask me, what do you mean by that? Okay, so encapsulation is nothing but assuming you've got a data packet, okay? Data packet which has got, hi, how are you? That's your information. Now, you know, remember in my previous lessons, I said, you know, we kind of enclose that in an envelope, and on the envelope, you will have address and all these things. There are cases where you sort of seal the envelope, right? You kind of seal it. That process of sealing it with some information is called encapsulation. This is just a dumbed down version of encapsulation as a how do I put it? You know, explanation to you. What is encapsulation? Encapsulation is nothing but concealing the data or adding information to the existing data for some functionalities in the future. So it kind of, you know, say for example, you know, if you want to carry a confidential information one place to another, you to sort of encapsulate that information with some information, and then on top of it, what you do, you also do a kind of passcode or encryption and those kind of things. So all of those functionalities are managed by the application layer. So all that encapsulation of information for to enable future transport is done by the application layer. Because in a network space, an operating system is also called as an application. So bear in mind. So don't don't get confused with, oh, a Zoom is an application, but why is Windows an application? For me, it doesn't really matter whether it is Zoom, whether it is Skype, or whether it is any that software. What comes out of it is from the device, which is what is the physical to hardware physical to that application bridge. It's the operating system. So all of that bundled together is, to me, an application. Make sense? Yep.
Yes, sir.
Okay. All right. So so TCP IP sort of started being the gospel for a lot of these devices going forward, and that's why TCP IP became popular, and because the implementation of TCP IP was much more easier and quicker. Now, I'm going to talk, I'll come back to UDP. Before that, I want to talk about something specific, and then I will talk about UDP. Okay, now let me clear this, clear all drawings. Okay, now, say for example, there are two devices, okay? That's a computer. And there is a mobile phone. Okay, now these two devices, you have to send a message from one device. So you use, what kind of application can you use? You can use Skype, for example, right? Skype. Oh, my bad handwriting. Skype. Now this has got another Skype, for example, right? You sort of send information from one device back and forth. Now, as a first step, I don't know if I don't remember if I said this to you before, right? So there are quite a lot of devices like your modem, your broadband network, on all of these. Okay, for the sake of this discussion, let's assume in some way, shape, or form these two devices are connected. Okay, now when you send a packet, when you send an information to the other device, what happens internally? It's a bunch of stream of packets flowing from one device to another device. Correct? Yep. Now,
Yes, sir.
so this transfer of device from one to another is needs to have some kind of structure. I'll tell you why. Say, for example, you are I'm talking to you in a class. Okay, this is probably not a very cool example, but just for you to understand. Okay, I'm talking to you. How do I understand that you guys are getting what I am talking about? Because you are in some part of the world, I'm in a different part of the world. We are doing a video chat, and assuming that I'm talking to you, how do I gather that you people, whoever you are listening to me, are really understanding what I am talking about? How do I? So Ritesh, if you were talking to me, okay, and we are chatting, how do I understand that you are talking to me and I'm in front of you for a video? How will you figure out, okay, look, Ritesh, I said something to him. Does he really understand? How do you sort of get that feeling?
So like I would listen to the voice modulation, like if they
Yeah,
are like
yeah. If you're doing a
yes,
video chat, you sort of get
then I will get that.
you need an acknowledgement, right?
Yes,
Yeah.
sir.
Different people do acknowledgement in different format. Someone would say, yes, I get that, and all these things. Someone would actually shake their head, like any of our Indian culture is to sort of, yes, do this, do that, all of that, right? That way I'll get to know, okay, all right, so whatever I'm talking, it actually makes sense to that person, right? What is that you're expecting? You're expecting an acknowledgement. The acknowledgement could be like, doing a sort of thumbs up. It could be saying that, yep, I get it. Or it could be shaking head like this or like this, right? So
Yes,
only
sir.
then that is considered as a communication. Otherwise it's kind of, so otherwise what is it? So if you are sitting in front of TV and someone is talking in the TV, right? Do you acknowledge to him, or does he expect an acknowledgement from you?
No, sir. Like
No.
it's already
Yeah, because
it's
it's already,
recorded.
assuming that it's a live conversation, right? And it's you don't even call that as a conversation because there's no conversing happening. You only say that it's a broadcast, right? It's one-way traffic. It doesn't really matter if you are able to understand or not. I'll keep talking what I want to talk. That's a way of conversation. That's a way of sending out a message as well. But in a lesson, like if you were in front of your teacher would obviously expect you to sort of give him or her a form of acknowledgement for her to realize, okay, whatever I'm really talking about, that makes sense to that person, right? That's called acknowledgement. So there is one kind of conversation where, one kind of chatting where, that's a wrong word actually. Chatting is not chatting has to be bidirectional, right? There is one kind of communication where you sort of broadcast it. There is another form of communication where you expect an acknowledgement back. Correct?
Yes, sir.
So TCP IP believes in an acknowledgement back. Okay. But another protocol is there which does not expect an acknowledgement back. It actually follows the same standard. Okay, but it doesn't sort of, it actually doesn't, you don't expect an acknowledgement back. Okay, so there are two types of traffic, one with acknowledgement and the other without acknowledgement. Okay, the first one, which actually expects an acknowledgement, is TCP IP protocol. So any communication which happens through TCP IP, okay, any communication which happens through TCP IP has a two-way chatting happening as a prerequisite. Okay, so okay, now I said a Skype communication between two devices in this case, right? A Skype communication between two devices in this case, assuming that how does it work? It works in the form of, okay, so that's a message call. We call it in networking terms called Syn Packet. So if someone is trying to connect to another device through TCP IP, what it does is it tries to send a packet called as Syn Packet. Okay, so this device sends a packet called as Syn Packet. Okay, assuming that it reached the other device. Okay, TCP IP expects acknowledgement, as I said. So this guy will send another packet to this person, and that's called ACK packet. Okay, so this is the protocol it is using. Now, once this is A, this is B. A sends a Syn packet first. B replies saying that, hey mate, I got your packet. That's called ACK packet. Now that it doesn't stop there. A will send a reply back to B saying that, hey, I received your ACK. That's called SYN-ACK. This is how on a TCP IP communication, this is how a network communication starts. A network communication starts by sending a Syn packet to the destination device sending an ACK packet back to the source again sending another packet saying, I received your ACK, which is called a SYN-ACK. Make sense? Only if all the three communication happens and completes successfully, it will start and that's called as a successful communication. Pritish, you were asking me something.
So, but then like we can also communicate like this with the OSI packet, right?
No, no, OSI is not a packet. OSI, okay. So all the Syn packet, ACK packet, and Syn ACK packet goes through the OSI layer or the 7 layers of networks.
Okay.
Because the packet which goes from A to B will have the information like what is the destination IP address, what is the time at which I am sending, what is the session information, what is the port number to which it has to communicate. All of that information is available in that communication channel. But as a prerequisite to establish or continue with the communication, TCP IP protocol stipulates that, or TCP IP protocol mandates that you send a packet, test whether that person is reachable. If that is reachable, he has to send me a packet back. Then I will send you a packet in reverse saying that your acknowledgement has been reversed. Only if this three-way handshake happens will the next set of communication continue. Otherwise, the communication is stopped. I'm not able to receive any acknowledgement from my target, so I'm stopping this communication. I'm done with.
Okay, sir.
Okay, so that's how it is. So the mechanism, there are two different protocols. One protocol is TCP IP implementation. The other one is called UDP implementation. You know what is a UDP implementation? A UDP implementation of OSI do not expect the acknowledgement. They don't care. I don't need to want a response from my destination. I will just keep sending it. So in reality, the chatting that I'm doing over the Zoom application is actually, you know what protocol it is, or what kind of packet it is? It is a UDP packet. I don't know if my chatting will actually reach you, or the device that I am sending from do not actually know whether that packet which he sent to the other device is actually reaching the destination. But if you are doing a chatting, okay, wherein which the connection is always required to be available, that sort of communication, I'll tell you exactly what the communication is. If, for example, you are dialing into it and then you're sending a passcode, yeah, that particular connection wherein which you are sending the passcode in the Zoom session, that particular part of communication is on TCP. But the video and chatting that I am doing over voice is not TCP IP. So in any data communication, there can be a combination of TCP IP traffic, and there can be a combination of and UDP traffic. Make sense? In both TCP
Yes,
and UDP case, okay, it actually follows every of your application OSI layers. Your you know, data link layer, network layer, all of that is there. But the only difference between TCP IP and UDP is, in the case of TCP IP, you actually expect an acknowledgement from the the sender expects a acknowledgement from the receiver, and the receiver receives a acknowledgement to his acknowledgement. Is it confusing? Okay, I want to say, as pretend I want to stay connected with you, right? If that chatting between us two or us whatever is on a TCP communication, the method in which the two device stay connected is by sending a Syn packet to that guy, waiting for an acknowledgement, and the recipient of the first packet waiting for an acknowledgement from the recipient, from the source. So that sort of three-way communication is called as three-way handshake. It's like three-way handshake. Hey, both the parties know that each other is available or alive. If one of them dies or one of them gets turned off, obviously when I send a chat to that guy or when I send a Syn packet to the destination, he can't send an acknowledgement. Correct? Does it make sense?
Yes, sir.
Okay. So OSI layer, TCP IP, and then UDP. There are heaps of other protocols and implementations. So if you start talking about various other protocols, we can't really finish it in 10 or 15 sessions, right? And there are a lot of protocols being developed. Even I have not come across or I have not experienced working on it, right? There are specific protocols developed by certain companies themselves just to ensure that their traffic is not readable by anyone else. Okay, so there are security protocols available. Yeah, but in a very commonly widely used protocols are TCP and UDP. Okay, now let us talk about both TCP and UDP and do a bit of comparison. Okay, now let me clear this session. So we spoke about TCP. So there is no direct OSI layer protocol implementation anywhere. Every implementation protocols that are developed follow the OSI framework. OSI framework by itself is not implemented as a protocol anywhere. Okay, so that is the difference between a framework and a protocol. A protocol has its own rules, its own methodology of working, but it follows a standard. Okay, so like how do I put it? Like, you've got various in a country, for example, in India, you've got different syllabus. You call syllabus, or what do you call in that part of the world? Okay, so you've got a content, you've got a syllabus, and that syllabus is the gospel, right? And different schools teach the same syllabus in different mechanism, right? There are some schools which actually has technology. They actually give a practical application. There are some schools which are not really as equipped as some schools, other schools. So there are different ways in which people teach the same thing, but some are effective, some aren't, right? Like I am following a particular syllabus. Give me a minute. Sorry about that. So look, it can be just conceived as okay, OSI model can be considered as a syllabus, and TCP implementation or UDP implementation is just the way mechanisms by which they implement OSI model. Okay, and the reason why is because if you sort of stick to the same syllabus and the same wordings and all these things, it becomes very difficult for certain students to sort of grab it, right? What does that mean? And if pretend your teacher, for example, your teacher were going and then just reading what is there in the syllabus and just translating it to you, you wouldn't feel it so convenient for you to understand. So what they do is they sort of relate it to, okay, now look, some teachers would say, look, I've got a example at home where in which I can show you how this particular thing work. like a pendulum, for some of, you could take any example, right? There are different teachers teaching you stuff in different way. And that's basically because some people have got access to something, some people do not have access to something. So likewise, OSI layer is your parent syllabus, and TCP IP is an implementation of that syllabus, but with some customizations just to make it convenient for certain communication channels to work. So, but okay, each way of communication, okay, each methodology or each implementations of this OSI layer has some benefits and some drawbacks. Okay, let's discuss about what are the positives about TCP IP over UDP, or what are the what are the main differences, what are the pros and what are the cons. Okay, in the case of a TCP IP implementation, one of the most positive part of TCP IP communication is why is that called reliable? Can one of you tell me?
So because it checks the acknowledgements of both the devices, and like it sends the signal and it checks if the signal is received by the other communication device, and then it again acknowledges the signal is sent back to the same device which sent the signal to the communication device, and it gets acknowledged. So it is more reliable because it knows the correct device instead of going to, like, it doesn't manipulate to other devices. The signal doesn't go to other devices. It goes to one device and it acknowledges and it confirms that this device is the device we need to be communicating with.
Okay, any other answer? Any other answer? Navjeet, Suman?
No, sir.
I can't hear you. Is that because your connection is a problem? Your UDP packet is not reaching me. Look, Ritesh, it was the best answer, and that's the answer. I'm so happy. I'm so happy that you understood what I said. Mine was a TCP IP transaction then, isn't it? You acknowledged it by giving me the right answer. Thank you very much, Ritesh. I'm so happy that you are listening to the session. It's actually giving you a bit of understanding. Okay, that's the answer, reliable. And the UDP obviously is not reliable, so not. Okay, not reliable. Okay, now, obviously TCP IP has that as a positive. What could be the negative part of TCP IP, and what could be the negative part of negative part is not reliable? What could be the negative part of TCP IP, or is there any positive side to UDP? Ritesh or anyone else can answer that.
So, like, while communicating with TCP IP, we get a lot of traffic because it might go and come back, and sometimes the signal might be weak and we can't get the correct, like, we can't communicate properly.
Okay.
But with UDP, as it is just a single signal, we can, like, communicate faster than TCP IP.
It's a very good answer, Ritesh, and that's 75% of the answer. It is not about bandwidth or something. Just because of the nature of implementation, TCP IP is slower. And as you said, exactly the same reason. For TCP IP to work, it has to wait for a packet to be thrown, reply. So it's a lot of time because a lot of things happening. So every chatting requires a acknowledgement, the acknowledgement to be re-acknowledged back, right? So a single traffic which could have reached there in, say, for example, I mean, 1 second or 1 minute, actually has to wait for 3 times of that same chat, correct? Because you actually send an information, that's 1 second. Pretend that it is reaching there only in 1 second. The reply, obviously it is using the same channel. The reply is another 1 second. Now, the third traffic is what? The reply to the reply. So for a reliable communication, obviously it is reliable. And for a reliable communication to happen, it has to wait for the entire cycle to be complete, which is not a very desirable way of doing things, correct? So how do you, and UDP on the other case, just following what you said, UDP on the other case do not require these levels of protocols. I mean, these levels of, for want of a better word, these levels of red tapes. I send it. If you receive it, well and good. Otherwise, I don't care. I keep sending it. I keep sending it. And that's exactly what is happening in video communications. In a video communication, it's all UDP because it needs to be quicker. It needs to be faster. Because how does a video get presented on your screen? A video get presented because trillions of small bits. Okay, if you slice and dice your video screen, trillions of small bits get transferred from the originator to the sender. Now, for each of those bits, imagine if you had to wait for an acknowledgement, it will never happen. It will never happen in time. Correct?
Yes, sir.
So for certain transactions, the application which is sending it is capable of thinking, what is my end objective? My end objective is my end objective to ensure that the person receives it? If it is not, it will just select UDP as its means of communication. If it thinks that I need to ensure that the person who is there is available all the time, then it does chatting over TCP IP. So when there is no requirement, or there is a performance requirement to make it quicker, then it is UDP. If there is no performance requirement, but the stability is the importance, then it is TCP IP. Make sense?
Yes, sir.
Okay, so an HTTP transaction, www.google.com on your browser, that text goes to the other end on a TCP because it is reliable. It has to be a reliable communication. It has to ensure that the right source and the right destination are able to chat to each other. But in the case of a video chat, which is Zoom is using, no need. I will start performing poorly if my communication on video was TCP IP. Correct?
Yes, sir.
Okay. Obviously, TCP IP becomes slower, UDP becomes faster. There are, yeah.
Jay, aren't the protocols which gives acknowledgement only for a session, like not for each packet?
Depends.
More efficient?
Depends on which type of communication you are doing. And say, for example, if it is a client server activity, the client and the server, in case of an app to database connectivity and all these things, they keep chatting and they keep sending synact. So, but as you said, it is for a session. It is not for all the communication. It is for a session. A session gets established for the okay, I'm coming next to that right now. If you have A as your computer and B as another computer, Okay, now this is what example do I take? So let's take the example of online ordering system. Okay, end user sitting here and then opens a web page. What is your common e-commerce site in that part of the world? Do you use Amazon? Amazon.
Yeah.
Amazon has a server here. Right now, this guy establishes a connection. So pretend that, all your modem, all of that is established. What happens when you log in? So you've got your user ID, you've got your password. The password and the user ID has to be, so you enter your user ID, say J is my user ID and I've got a password ABC123. I enter both username and password into my screen. What happens is the client or the source, which is A, is trying to send a packet down to B or up to B. Okay. In this case, what happens is both A and B sets up a communication channel. Okay. Which in another format is called as a session. For this session to be active, that is when they do this three-way handshake. So how does the session gets established? The session gets established by using something called as ACK and SYNAC. Once the three-way handshake is complete, the session gets established. You can imagine the session as a pipe between two, so like a pipe between two devices. Okay, the water flows from one bucket to another bucket. It keeps traveling. Once you have the first packet coming back, going back, the pipe get established virtually. Okay, once that session is established, until you hit the termination of that session will be active, which is called as an active session. Okay, is it confusing, Ritish? Because I'm only able to see Ritish, that's why I'm keeping on calling his name. Others, please don't, because for me, Ritish is a semi TCP and the others are completely UDP for me.
One more doubt, Jay.
Yeah.
So, like, even if that network
Yeah.
where the packets are being sent, the route in which the packets are being sent, even if it faces a congestion, all the packets in a session follows the same route, same network route?
So it depends on the application that you're using. So there are some applications which has the inbuilt capability of resending the packet if a session is not getting established. Okay, so there are two things to it, right? I didn't want it to make it so confusing, but just to answer you, Satish, there are two things to it. One is a session information. Then there is called as a session timeout. A session timeout is nothing but the operating system or the source application maintains a timeout value saying that if I don't see any chatting happening in that session, I will keep the session alive for whatever number of minutes or second, whatever you have configured. And if I don't get any traffic during that session, I will just terminate the session. That is the smartness you built into the application, either on the source side or on the server side. It is usually done at the server side because server is more busier than the source. So if you have a web server, for example, the web server always has got, if you have an Apache web server running or a Tomcat web server running, for example, they have something called as a TCP timeout parameter. The TCP timeout parameter is usually set because to avoid congestion. Because pretend a scenario where there are hundreds of sessions getting established and it just no one does anything, it just keeps there. So you might have experienced this. So certain applications are smart. They will send you an acknowledgement saying that, hey, my friend, your session has got timed out. You can see that mostly in your banking sites, because banking sites follow a particular security standards. Banking types sites ensure that the user is informed of every single thing that is happening. If you don't, it is a legal entitlement. If I don't know what is happening and I keep sending data, there are masquerading techniques wherein which people could absorb that information. Any third party can come in the middle and capture that information. Multiple things can happen. To save or to protect themselves from that kind of problems, a bank will definitely tell you, hello, my friend, you were inactive for 5 minutes. I am terminating your session, or I am timing you out. You might have seen this in any of the banking transactions or any of those transactions. Okay, so coming back to that. So that's about session, right? What was I talking about? Yeah. So in a 3-way handshake, in the case of Amazon.com, until the password is reached, you know, then Amazon will establish a session, and the session keeps getting active. Okay, just stay with me for a minute. So we said session information, right? Just play back to your OSI layer. Which layer do you think will maintain the session information, or how do you think the application or the server, in the case of Amazon, will ensure that the session information is active? What layer would that be? So you establish a session between your server, which is your Amazon.com, and yourself, which is your PC. There is a session getting established. But that session information is available to both the parties through what?
So TCP IP.
Yeah, TCP IP, yes. But remember, TCP IP is also using the reference model is OSI.
OSI.
Okay. In the OSI, there are multiple informations at multiple layers. Remember, you've got your application layer, presentation layer, session layer, and all of these things, right? Which information, based on which information would it be handling the session?
So application, data link.
No. In the case of TCP, you are right. But in the case of OSI, which layer of OSI? So TCP using OSI model, remember?
Yes, sir.
So which layer information of OSI would it be using to establish the session?
So data link.
No, it is the session layer. It's simple.
Okay.
So OSI layer has got 7 layers. One of this is application layer, your presentation layer, session layer, presentation layer. Presentation layer maintains the information of the protocols which it is using. Application protocols. The data link layer stores the data information in terms of the MAC addresses and things like that. A network layer will maintain the information of the IP addresses. What is my source IP address? What is my destination IP address? A presentation layer uses what kind of presentation, if there is any encrypted packet going, if there is any, what is the application protocol it is using, whether it is HTTP 80, HTTP 443, what protocol is it using? Is it a secure packet or is it an insecure packet? Those kind of information goes into the presentation layer. All of that in the, yep, go for it.
So, but won't the data link layer help in sending and receiving data?
All of this help in sending and receiving data, but each of that data packet is split into 7 activities or 7 things on top of data. Application information, presentation information, session information, data link information, network information, everything together. I was checking with you which layer information would it be using to maintain the session, which layer information would it be using to maintain the route, which route to take. How does it know? It's based on the IP address. Which device to which switch it has to go, maintained by data link layer. Which what did I which protocol is being used, maintained at the presentation layer. Which session is used, maintained at the session layer.
Okay, sir.
Okay, so every packet that goes out of a server A or source A to destination B has a packet. A packet can be considered as a big slice of information with different 7 layers. And each layer has got some information. All of those informations are used in some way or the other in the entire sequence of communication. And that is how in a network artificial intelligence and network data capture, how do they collect all this data? It's based on the packet information that you have. Eventually, it's just the packet information which helps people analyze data. It's the packet information which helps people do security things, like, you know, people might come in and then read your information, which is which do not belong to you. There are a lot of security issues, hacking, and these kind of things happen by reading this data packet. That is how someone would read your data packet. To cover that, I'm actually rushing in because I've got to finish 2-3 things to you. I've got to give this packet information will help in analyzing the entire sequence of the travel path. Okay, so like you're going from one place to another, what are the routes you take, what did you do in between, or how many luggage did you carry? All that information is enclosed in that packet. So what is the size of the packet, where is it going to, what is the session at which it started, you know, am I sending the right packet, or am I securing the packet by doing something else? All of that information is contained in that packet. Okay, there are different devices which reads that packet information, which are really proprietary. Like I said last time, a data link layer, a switch will read the data link layer. A network router will read the network layer. Then comes the interesting part. Then there is something called as a firewall. Have you heard of this?
Yes, sir.
Okay, what does a firewall do according to you?
So, like a firewall blocks the access of a third-party device to the packet from accessing the packet.
How do you think it happens?
So, because I'm not sure of how it happens, but I know
it happens. It happens by reading the data packet information which is flowing through it. So, assuming that, remember I said source and destination. Just pretend that those are the only 2 devices available. Just pretend that there is a device in between which actually reads the packet which is going from this direction to this direction. It's like a policeman. So whatever information flowing through it, this policeman can see it. This policeman can see every packet information. So based on that packet information, it will actually decide whether the information is the right information, the information is going to the right place, the information is authentic, or does it have anything else. All of that intelligence is built into this man in the middle, which is called as the firewall. Okay, guys, have a good time. Enjoy your holidays. All the best for you. In case we don't talk soon, if we talk, we can catch up later.